Today we're going to take a look at another technique for finding limits. And it comes from the idea of continuity. Now you may recall from continuity, both the limit and the value of the function have to be the same number. That's our definition basically of continuity. We can use this to help us solve certain limits. This is our first technique and we call this the substitution method. Now, to find the substitution method for limits, all we're going to do is we're going to plug in the x value. So for example right here, if I want to find the limit as x approaches 3, I'm just going to plug that into each of my x's. And that gives me 3 squared plus 3 times 3 minus 1, which is pretty easy to do. 9 plus 9 is 81. 9 plus 9 is 18. So this becomes 18 minus 1, which is 17. And there's our limit. If we try number 2, plugging it in, there's my negative 4. I get negative 4 plus 3 over negative 4 minus 4. And we get negative 1 over negative 8, or 1/8. Notice, in the substitution method, we are actually finding the value. The substitution method, we are actually finding the value of the function. Why does that work? It goes back to our continuity. Because of continuity. And what continuity says, that if a function is continuous, the limit must equal the value. So because I get a number here, this value has to equal my limit. Therefore, the value is the limit. So if you know a function is continuous, we know that the value has to equal the limit. And that's why substitution works. Tomorrow we're going to start taking a look at what happens if it's not continuous. All right, so let's take, or other issues. So let's take a look at number 3. Ready? If I want to find the limit here, I plug it in. I get 0 squared plus 9. Well, that's just 3. These don't take long to do. Plug in 3, negative 3, I'm sorry. We get 5 times negative 3 over the cubed root of, plug in your negative 3, plus 6. We get negative 15 over the cubed root of 3. I don't know what that is, so I'm just going to leave it. Let's try number 5. Plug in the 4 for our x. 16 over negative 4. Oh, what do I get? Negative 4. Because I get an answer, we know f of x is continuous at x equals 4. And that's what this means. And because it's continuous, we know its limit must exist also. And like I said, tomorrow we're going to deal with, well, what happens if we don't get anything here? Like 0 over 0 or undefined or something other weird stuff. So tomorrow we're going to take a look at what happens if it's either not continuous or we get some weird functions. Let's try number 6. Plug in your 3. 3 cubed plus 1 over 3 plus 3. What's that? 3 cubed is 27, so I get 28 over 6. You can reduce that to 14/3 if you want. Ooh, 7, a trig question. Plug in the pi. We get the cosine of 3 pi over 2. Well, that's easy. We should know that one. That's in the... There's 3 pi over 2. Cosine at 3 pi over 2 is 0. Let's try cosine. And a miracle occurred. So, let's take a look at the cotangent. Plug in the pi over 2. We get the cotangent of pi over 2. Now, I don't know what cotangent is, but I know what tangent is. Tangent of pi over 2 is dne, which is really saying it's 1 over 0. So to get the cotangent, we flip it. And what do we get? 1 over 0 just becomes 0. Remember, we're going to flip that bad boy. Let's try number 9 and 10. So for number 9, if I'm looking for the limit of the arcsine, be very careful. We're going to get the arcsine of 1. Remember what this is saying. What angle has a sine of 1? And that's easy to do. So we're going to write this as we rewrite this as the sine of theta equals 1. And what does theta equal? Very easy. Pi over 2. And there's our answer. See if you can try number 10 on your own. A little bit tougher question right there, okay? And then go on to part 2, and we'll take a look at the rest of the notes with the piecewise.